Welcome to Homework Lib.
Alright, so first let's draw the diagram of this question and see what's the problem, what is the problem about. So we have a water wave which is traveling towards the shore, but just before the shore there is an obstruction, a wall with a hole. So let's call the width of the hole to be A. So this distance is A. Now the distance between wall and shore is also given to us. Let's call it x, and this is right here 3.20 meter. 3.20 meter is 320 centimeters, right? Now you, now just observe that if I call the shore to be a screen, then this is nothing but a single hole diffraction problem. So as any diffraction problem, so there would be a wave which would get diffracted here, and we would get the usual diffraction pattern, right? So now forget about the water and all those things. So the problem is reduced to this thing. There's a wave which passes through a slit of width A, and we are seeing the diffraction on a screen. Now there are two important things that are given to us. First is velocity and number of crest passing per unit time. So we know velocity 15 centimeter per second and number of crests per unit time. So we have 75 crests passing per 60 seconds. From these two informations, we can find out the wavelength. How we can find out? So there is a relation between lambda and velocity and time period, where t is time period. But so we know the velocity, but we don't know the time period. So now this comes handy. The definition of time period is the time taken to complete one oscillation. What is one oscillation? One oscillation is just that is time between two crests. So here we know that there was 75 crests in 60 seconds. So how much time does it take to for one crest between two consecutive crests, which is this thing 75 by 60. So we would find the t time period, plug it here, and get the lambda. Other key feature, other key thing that is given here is that there is no wave reaching the shore at 61.3 centimeter, and waves do reach the shore everywhere within this distance. So which minima are we talking about here? So if you would recall that that's how the diffraction pattern looks like. So this is the maxima around the center 0. So the first minima occurs here. Everywhere else between these two things is maxima. So the distance 61.3 is the position of first minima. First minima. So we are given y1. Now all that is left to do is to use the formula for the position of minima, which is given in the book, and it is ym is x, let me make small x into m into lambda divided by a. Maybe I can remove this thing to make it less confusing, right? So here we know the x, we know we are talking about first minima, we can find the lambda, and we also know the position y1. Now in the question it asks to find the width, so this we can calculate. So now let's begin the formal solution. The formal solution begins now. So the time period, first thing, time period T is equal to number of crests upon total time, 75 by 60. Velocity 15 centimeter per second. Wavelength lambda is velocity into time period is 15 into 75 by 60. Put it into the calculator and you would get 18.75 centimeters. For first minima, using the formula y is equal to x lambda by a. Here, since m is 1, we all know we are talking about 1. So whether you write it or you don't write it, same. So now we want to find the a. So let's bring a on the left hand side. A is x lambda upon y1. So x is 320 into lambda 18.75 divided by 61.3 equal to 97.87 centimeters. So this is the width of the barrier, the width of the hole in the barrier. Now in the second part, they are asking to find the angles for which no wave is hitting the shore. That is, we need to find angles at which minima occurs. Now we just have to use a simple diffraction formula, which is sine theta is equal to m times lambda by a. Plugging all the things, m is m, lambda is 97.87, and a is, no, this is a, sorry, lambda is 18.75. So this thing becomes 0.191 m. So the position of, so let's make it general, so let's sine theta m. So so now for small angle approximation, sine theta is just theta m. So it's 0.191 m. All right. So the problem is, first we have to remove all the junk that is given in the problem, like water, shore, all those things, and try to understand what is the useful thing given here. So we need to know the distance between the slit and the screen, the position of the first minima, and the lambda. So everything is given. So first we need to figure out the lambda. So either lambda would be given directly, or we can find it out from the velocity, and some information would be given through which we can find the time period. Once we get the lambda, gen see whether we need to find the width of the hole, or we need to find the ym, the position of the minima. So these are the formula which we need to remember. Let me write it again. Formula used ym equal to x m lambda by a, and sine theta m equal to theta m equal to m lambda by a. So these are the formulas that would be used. So we just need to figure out what is given and what we have to find. All right, I hope you understand